Hello, everybody. This is Dan Helfrich from ZBand. We only have about 25% of the registered attendees that are on at this point in time, so I'm going to give it another minute or two before I officially get this thing started. The format for today is I'm going to start with an overview of basically the ZBand system, and then roll into some particulars about the Distribution ZHC and the 5th generation of product that are unique to that product. But I am going to give it a minute or two here until I get started. Probably be about 2 after 2 when I begin the full presentation. Okay. When I started, I had all of this. Like you chose.
I can start it along with you. Like if I could have just hit start. That's we're both organizers.
Yeah. I got 20 seconds even trickling in. So I'm kind of waiting a minute here. And all right. Hey everyone, this is Dan again. I saw about a half dozen people jumped on here in the last minute or two. We are now at about 50% of the registered attendees that have jumped on, so I'm going to give it another minute or two before I get started, just to let anyone who stuck in another meeting or on another phone call trickle in before they miss anything. For your information, this is a one-way webinar. All of the attendees are currently on mute. If you have questions within your GoToMeeting panel, GoToWebinar panel, there should be a drop down where you'll be able to chat in any questions to us. Depending on how this goes, we may answer questions at the time, or we may collect them all and send out emails to everyone after the fact. I don't want to push anybody for time, so we'll see how the timing of this goes before we make a decision on the Q&A at the end. Again, Dan from ZBand, and I'm going to give you about another minute here, and then I'm going to get started with the presentation. All right. Good afternoon, everyone. My name is Dan Helfrich. I'm a vice president here at ZBand Technologies. And the purpose of the webinar today is to give everyone an interview of the 5th generation of our RF video distribution system, which is our Distribution ZHC. The format for this webinar, everyone is in listen-only mode. So if you have questions, you can chat them into us through your GoToWebinar panel. What I'm going to do from a presentation standpoint is I'm going to start with some basics of the system. So there's a wide range of customers that have registered for this webinar. Some people are very new to the system, maybe about to install their first product, and some of our attendees are longtime customers. So the first 4 or 5 slides may be review to our long-term customers, but I felt they were necessary to include in this presentation. So we'll start with the basics, what ZBand is, how we do what we do, and then get into the particulars of the 5th generation of the system, what makes it unique, and how we feel it's going to be beneficial for our customers. So again, if you have any questions, feel free to chat them in, and I will, if it's something that I've missed throughout the presentation, I will stop and answer it. But most likely I'll wait to the end and add things on at that point in time. So the basics of the Z-band system, for those of you who are new to us, is we use category cabling to distribute television signals. And what makes Z-band unique is we use that category cabling not to distribute IP data, but to distribute RF video. So we're not actually taking everything and putting it on the network. We're just using that category cabling infrastructure and single mode fiber on the backbone and sending it out. So it makes us different than what you would consider to be an IPTV system, in that we're not actually transcoding the video data to IP. It stays as RF. The other thing that we're different than, but are commonly confused for, is like an HD-based T system or a baseband system. Z-band is RF broadband distribution. So every channel that is on your incoming cable TV feed goes out to the television. So if you've got a 10-channel system, if you've got a 20-channel system, if you have an entire cable feed from a service provider, all that goes down each front panel output port and is delivered to the TV as is, with no manipulation to encryption, video data, closed captioning programming. None of that is changed within the video platform. At our most simple, we are a distribution platform. We are a mechanism for moving video from point A to point B. Now, we personally feel that we are the best mechanism for moving video from point A to point B, but at its simplest, we want to make sure that it's known and that it's out there, that we're not doing anything in terms of manipulating that video data that's going to cause latency or mess with encryption or mess with digital rights or anything like that. So it's important to get that out there at the beginning. We're taking RF video in, and it's RF video the entire time that it's being transmitted through the Z-band system. As Z-band, one of the most common questions, one of the most common issues that we have is dealing with service providers and the ever-changing landscape of how content is being delivered to different facilities and infrastructures at this point in time. And as you'll see on the right, I will not cover all of that in detail, but each service provider seems to have their own way of doing things. You'll have cable TV providers that will provide business class feeds, which are unencrypted in certain geographies and then not want to provide them in other geographies. You have satellite providers, which each make their own proprietary down conversion device and install those down conversion devices through a list of registered distributors and resellers. It is an important note here for, again, the Z-band system in general, that we do not support a raw satellite feed. So if you are, let's say, a sports bar and you want to take your incoming DirecTV feed and put it to 20 different televisions throughout your sports bar and put your own DirecTV box behind each television, that's not something that the Z-band system can do. And it's not a function of the Z-band system exactly, more a function of category cable. Satellite video is transmitted on extremely high frequencies, and the physics of transmitting those frequencies over category cables makes it impossible to do it over any sort of distance. So satellite, just as a general rule, can't be transmitted over category cable unless it's down converted to lower frequencies or transcoded to some sort of other delivery format. It's very, very difficult to send satellite as RF over category cable. So what we do most of the time is work with a DirecTV or a Dish installer to put in a COM3000, COM2000 smart box, build a head end. There's a variety of different options when we get into those scenarios. So at its simplest, again, what we're doing is interfacing with the cable TV provider. In most of our projects, we are aware of who that provider is and have some conversations with them ahead of time to make sure that everything is in order. And then everything goes into the Z-band video system. So I'm going to actually start in now on some Z-band specific products rather than the industry general knowledge. Once we are started into the Z-band video system, what the Z-band system does is it takes in a CATV signal or an MATV signal from the service provider and uses our front panel ports to distribute that video out using the category cabling, but not on the network. And so we have a variety of different video hubs that communicate with balins to send video. And the basic infrastructure is that the hub uses this front panel RJ45s to send video to a balun. Along with that video, the hub will also send 8 volts DC to the balun, and the balun will read that and will make adjustments to the video signal based on how far away it is, based on the loss of that 8 volts DC. That 8 volts also line powers the balun, so there's no local power supply. It's not a quote-unquote PoE system. It's a power over category cabling system, but that power is unique and specific to the Z-band infrastructure. You can cascade hundreds of hubs together. I think our true capacity from a system standpoint is over 14,000 video hubs, and that cascading is done via either single mode fiber or coaxial cable. And we, again, as Z-band assist with those infrastructure designs, we'll do those drawings so that you can come back to us with what you believe should be going on, and we'll cross it off or potentially make recommendations depending on what it is that we see coming in. So again, the point of this is now giving you a completely self-contained video infrastructure using your category cabling, not using any coax, and also without the need to do multicast configurations, without the need to allocate bandwidth on your LAN or your WAN for IP-based video systems. This is using that modern IT infrastructure without all of the network impact. And I'm going to jump in here and just show you a quick slide as to how that works from hub to hub. When we're looking at it from hub to hub, we have a relatively simple method of cascading video hubs together. And so I'm just going to trace this through very quickly. And again, this is the case for all Z-band video systems. We're going to have our RF input source. And going back to the earlier slide, that's whether it's cable TV, satellite, doesn't matter to us. We're going to have that internally generated sources. All of them get into this RF input source bucket. Normally go through an amp because we do want to hit our master unit at 20 dB MV flat for digital video. And then that master hub can cascade to, you see 8 outbound ports on the back here, 8 different satellite units. And you see here, this is important to note for my system designers that I saw on the call, this is a true cascade and not a daisy chain. We're running from floor 1 to floor 2, floor 1 to floor 3, floor 1 to floor 4. We're not daisy chaining from 1 to 2 to 3 to 4. And that's important in the system because each time we go through one of these cascades, we're also doing some adjustment to the video signal, whether that's amplification, sloping, attenuation, and that can introduce noise into the system. So our system designs, we want to minimize the amount of levels that we have in the system. So we have a master here, and then all of these are level 1 satellite units, and it's a very efficient design for the system. And we'll max, as you can see on the bullets over here on the right, this is going to take advantage of our AGC. And for those of you who are very familiar with the system, you're already noticing with this drawing our first change and introduction to the Gen 5 platform is that there are only 8 outbound coaxes on the back here. None of the inbound ports are populated in the 5th gen of the system. And what you are seeing here is a single input port. So traditionally we've had an input and a cascade in port or a cascade out port. There's a single input that goes on the back of each hub, and then the hub is going to do a slope of various frequencies to put itself in either master mode or satellite mode, depending on what it sees for those incoming frequencies. So the hubs now in the 5th generation are intelligent enough to decide whether or not they're master units or satellite units based on what they see on this single CATV input. And that's one of the first major changes with the 5th generation of the system. But again, this is just a sample drawing, sample architecture. You can come to us for these types of things if you're looking at a system design and just want to have things double checked. From the hub out to the balun, and I'll apologize in advance, this is my only super techie slide on this, I absolutely promise. What we're doing is we're taking that coax feed into the back of the video hub, which is 75 ohm unbalanced, and sending it over the category cable as a 100 ohm balanced signal, 180 degrees out of phase, and then going into the balun and converting back to coax. And the only reason that this is important, and then I put it in here, is what this does, and the way that we do this is what allows us to not care whether or not we're doing shielded twisted pair or unshielded twisted pair. The reason that it doesn't matter is because of this 180 degrees out of phase and this common noise choke that goes in each balun, which allows us to knock out any interference that's picked up as this signal sent down the line 180 degrees out of phase. So the reason that I put this slide into this presentation is for those of you that are out there doing system designs, or the couple of customers that we have on that are about to deploy new systems. The reason that it's not a big deal to us whether you put in shielded or unshielded twisted pair is that our system is designed to help eliminate as much of that noise as it possibly can. The balun is shielded. A lot of the components within the hubs and baluns themselves are shielded by design, and then this 180 degree out of phase helps us knock out any interference that we're catching, any crosstalk that we may catch in the category cable. And so this is the last slide on the overview of just kind of how ZBand works as a general system. And now we're going to get into ZBand as a specific technology and what we are doing about the 5th generation of the platform. So those of you who have been familiar with us since the company was founded back in 1999 are going to see some different things here. What's important is it's still very true to the core of who we are, right? We are RF, and we're an RF video company who has a great understanding of that market, how that market is evolving, and has done just an absolute ton of deployments over the last 20 years in healthcare, in corporate, in stadiums and arenas, to treadmills. I mean, we've done basically anything that you can think of in terms of moving RF video from point A to point B. And the 5th generation product is very true to that identity, while also bringing us into this Internet of Things world, the world where we want to control everything that we can and want to have software feedback on everything. So we wanted to adapt to that world that we're in and become more of a managed service for our customers while not losing the identity of what we are, which is an RF video company. And so I'm going to start with the hub and kind of break down some of the changes that we've made just physically and what they mean from an infrastructure standpoint, and then go into some of the software changes and make some of those jumps as well. So again, if you have any questions, feel free to chat them in. I see that we've got one or two already. That one's long. So to the person who chatted in the question about the 8 volts, we will send out an email answer to you on that one, partially because it's too long for me to view in my little window here. All right, so on to the actual physical changes of the device. The first thing that you're going to notice, like I said earlier, is we have the outbound coax, and we have eliminated all of the inbound components on the video distribution system. Those inbound components had traditionally been used for what we consider to be remote broadcast applications, and those remote broadcasts were, K through 12 wanted to do morning announcements from the studio, and then they had a camera with a T-channel modulator, and we're sending things back over fiber or coax to the head end and being turned around and put back into the system. we just don't see many of those applications anymore. And so there hasn't been a lot of need or a massive need from our customer base to support the bidirectionality that was there. And so those components are no longer in the box, and it allowed us to do a lot of simplification on the cascade and make our RF a lot cleaner. So it was a change that we decided to make. So there are no reverse path components, no T-channel components in the 5th generation of the system. And I will hit on some other stuff here a little bit later in the presentation that we think validates that from a future-proofing standpoint. The other thing to note is that because we have this single CATV input now, there's actually some intelligence to that input port, and when you are plugging in, it's going to do a scan of several different frequencies to look for a pilot tone. Hang on just one second, I need to take a drink. That pilot tone has traditionally been embedded in between basically channels 26 and 27 of a traditional RF frequency. And it would occasionally, especially in some of the early iterations of Gen 3, cause problems with channels that were surrounding that pilot tone and us maybe getting a little bit of interference on those channels. The pilot tone can now be moved to one of 3 different frequencies to eliminate the chances of us causing any interference on adjacent channels. And we can set that up per the customer's request through the management UI of the platform. The other thing that you're going to notice, which you've never seen on Z-band hubs before, is we actually have active RJ45. Now, the Ethernet port that you see here, which is right in the middle of the backplane, is always populated. On every unit, that will be a populated port. There will be an Ethernet board in there, and then the only option to the customer is whether or not they want to purchase the management software that goes along with that Ethernet board, and we'll get to the management software in just a couple of slides. And the other RJ45 that you see here is that we are in the middle of finishing up design on an integrated layer 2 switch that would reside in the hub. Our original intent was to just simply make this an unmanaged switch and throw it in there as an additional 24 ports that a customer could layer on top of their network. Our market research has shown that that's not necessarily what our customers want. So we are in process right now of developing and writing some software management of that switch that's going to layer in on top of the system and allow you to do settings, turn ports on and off, and have some control over the switch that is in the Z-band system. And again, this is us looking at future proofing. I know we've got a couple of healthcare customers on the call. We are starting to see more and more our system being integrated with patient engagement or EMR type technologies, and we wanted to simplify the system, simplify what it looked like in the closet, eliminate a lot of the top row patch panel stuff that needed to be done with Gen 3 and Gen 4, and so embedding a switch into the system seemed to be the simplest way to move that forward. And we have done that, and we'll be releasing the hardware and software components on that in the near future. Feel free to contact your territory manager for specifics on that. We do have some of it already worked up and are just in the process of writing software now. And then the other big change is the power supply is now all an external power brick. I know that doesn't seem important, but again, with some of the early Gen 3s, one of the major failures, and with a lot of the Gen 2s, the major failures that we saw were power supplies. Fans would get clogged up, the thing would overheat, and then the power supply would fail and had to be sent back, or you had to have an electrician on staff who was capable of doing those repairs. Here, it's just an external power brick, which we will have available. So if and when power supplies do fail, it's a much simpler process now for replacing that power supply. And again, all of these changes were geared towards better serving or better better being able to assist the majority of our customers. Front panel changes. These are relatively significant. Anybody who has seen the previous generations of the system is going to notice that the top row is gone. That relates directly back to the switch and the Ethernet board being embedded in the rear plane of the box. And rather than the previous 12 and 24 port configurations, we now have 8, 16, and 24 port options. That doesn't seem like a big change, but we did pull about a dozen projects at random from previous years and do some modeling on that. And the change from 12 to 24 to 8, 16, 24 just by itself was a 10 to 15% cost reduction to our customers in the projects that we modeled on that. As an example, we are currently working with a healthcare facility down in Florida who has 28 televisions per floor in a 9-floor tower. That would have previously been a 24 into 12 for us to successfully distribute video across each floor, which would have been 924s, 912s, and a lot of open or vacant ports on the ZBand system. That can now be supported with a 24 and an 8 on each floor, or a 16 and a 16 on each floor, depending on how you would like to do it. And gives us a lot better port efficiency and is going to be a significant cost reduction to customers who have those types of situations. And we see a lot of that, again, specifically kind of in the healthcare market, because it's very, very rare that we happen to get a multiple of 12 for televisions on any given floor. And so this, we think, is going to help us better serve our customers and allow us to produce a more cost competitive box. The other thing that, and it completely internal, I guess, or from a development standpoint, the other thing that moving to 8, 16, and 24 port devices did for us internally is gives us a much better, more consistent RF video signal. So if you are to measure the RF video output across the front panel port of each and every one of the 24 ports on a 5th generation of the system, your variance is less than 2 dB. It's very tight tolerance for the system, and that's better than we had been on previous generations of the system. And you would see that occasionally in previous gens as a power supply would start to fail and we couldn't produce the necessary amplification in the system. Some of the ports out on the edges, ports 1 and 24, would start to go weak with their signal. That will not be a problem in the 5th generation of the device because the RF loss internally is almost insignificant. And this is the cleanest and best RF box that we have produced in ZBand's 20-year history, and we're really excited about what it has been able to do from an RF standpoint. And so that's it for the physical changes of the balun, of the hubs. And I'm going to jump into the balun because it is a different balun for the 5th generation of the system, and then I will be showing some software. Sorry, I had a call come in there. I had to silence. So the new balun, from a form factor standpoint, it is exactly the same as what you have now. You're not going to notice any difference. All of the difference are on the internal components. The big thing that we did with the balun ZHC is that each balun is serialized, and the balun also reports its distance from the IT closet back to the hub. And that is important. When we get into the software, you will see that you're now able to get distance feedback on each and every one of these baluns. The other thing, and the reason that the baluns are serialized, is because the components for IR control and RS-232 control systems are populated on all boards of the balun ZHC. And so that serial number is what's going to identify the balun to, number one, a specific port on the hub, but then also a specific room in a given facility where we're using any sort of TV control platform, whether it's IR or RS-232. And we will jump into that. So from an external standpoint, you're not going to see any difference with the Balun, but there are a lot of differences internally that make it an upgrade over what we had been using previously, mainly because of the additional flexibility that it's going to add to layer on additional services later on in the life of the system. One thing that I wanted to touch on here before actually jumping into the software platform is compatibility across generations. So the video hubs themselves are completely cross-generation compatible. You can put a Distribution ZHC on one of the old Gen 3, Gen 4 systems. You can use it as a master. It can be one of the satellite units, and we can make all of that work from an engineering standpoint. The only thing that customers need to be very conscious of is to not put a 5th generation Balun ZHC on a previous generation Gen 3 or Gen 4 video hub. And this relates back to the question that was chatted in about the 8 volts. The impedance on the Baluns and the front panels are different across generations, and the 5th generation Balun and the 3rd and 4th generation video hubs are not compatible because of that impedance difference. And so we will have to be conscious of that as we're moving Balun ZHCs into any legacy infrastructures to make sure not to put them on the front panel of any Gen 3 or Gen 4s. It's not a big deal, and we're actually already addressing the situation internally, so I think this is going to be a pretty short-term issue, but it is one that we have to be conscious of for the time being. And so that is pretty much it from the hardware side of things. This is, again, just touching back on a lot of the major advancements that we have, and I'm going to jump into the software platform. So this is our existing software UI. Some of you may have seen a demo of this before. For most of you, this is pretty new. Let me actually go back to the main page. So what we're trying to do with the 5th generation of this system is using the Ethernet port that you saw previously on the back panel. We are going to be able to communicate with each and every one of the video hubs in the system. And those communications are going to be important from a technical and troubleshooting standpoint, and then important also from a system monitoring standpoint. So when you log into the UI, and as you can see here, this is just locally hosted on my machine as a demo platform right now, you are going to basically get a complete system tree. So you're going to get serial number, any locations that you put in for the pieces of equipment, IP addressing, the status of the hub, whether it's online, offline, whether there's been some sort of issue or whether there's a change. Changes are most likely going to be connecting and disconnecting of Baluns or connecting and disconnecting of cabling on the backbone, and we want to notify you of any of those changes that have been made. And then also the number of Baluns that are connected to that hub. From this screen, you're also going to be able to drill down into any particular hub and say, okay, I am actually looking at what I have in this hub right now. So in this hub, I can see I have 14 different Baluns connected. They happen to be in ports 1 through 14 that they were populated, and I've got 3 different outbound coax connections that are populated. The color coding that you see here, the final version of the software will have a legend built into it, but that color coding is going to correspond with the LED lights that you see on the Balun. So to any of you who have installed our system before, as soon as you plug in to the 2-wall RJ45 jack that's on the Balun, the way that you can tell that the Balun is receiving a signal from the video hub and that things are active is you will get one of 4 different LED colors that will populate on the Balun through the pinholes that we have there. And those balun are signifiers, one, that the balun, those lights, sorry, are one, signifiers that the balun is getting power. And then two, the lights correspond with the distance from the video hub that the balun believes it is. And these lights that you see here are going to correspond with the lights on the balun. So if you have a balun in the green bucket, you'll get a green signifier here. If you have a balun in the yellow bucket, you'll have a yellow signifier here. And that will allow us to get an idea of how far each category cable run is just as soon as you log into the UI. Other thing that you can do here, we go into the front panel, is you can build a complete system tree. So we're going to get the status of the balun, whether anything's changed, what room it is, and then configuration is actually the ability to go in and turn ports on and off. And again, the final version of the software, or release 1.2 of the software, will have this feature that you can set on a timer so that you'll be able to turn those ports on and off on a schedule. It's not TV control, it's not passing that all the way out to the television, but the applications that we have had for that, or that customers have requested for that, are in places like children's hospitals where we want to turn TVs off in a certain wing at 12 o'clock. We've had some correctional facilities who are interested in this, disabling services at certain times. And then you can just turn the port off altogether. So you will have the ability to go into the UI, turn ports on and off, and do that through the system. The other thing that you can do here is go in and take measurements. And this is important from a troubleshooting standpoint, and then also for us from a consistency standpoint, just making sure that the system is functioning the way that it's supposed to. And the nice part about this is these scans are going to be agile. You can change the start frequency, change the end frequency, scan specific channels, scan a range of channels. You have the ability to go in here and make these measurements yourself on individual ports. Let me go back. Or on the incoming feed or outbound feed to the hub. So if you have a multi-story facility or a multi-wing facility, and everything's good at the master unit, everything's good at level 1, but by the time you get to level 2, you're starting to have some problems. What you can do is actually go into the admin portion of the software and take a look. Okay, well, outbound of my level 1, everything looks fine, but when I get inbound at level 2, I have problems. Maybe we need to shoot the cable and test the cable, or you're on the edge in level 1 and then you have problems in level 2. Maybe there are issues at the master. It's going to allow us to be a lot more effective, both remotely and when on site, in troubleshooting the system and making sure that we are getting good feedback. Because, I mean, one of the biggest problems that we have as a company in troubleshooting is we sell, 100 systems, a couple hundred systems a year in terms of RF video distribution, and the majority of our customers are not as RF savvy as what some of our technicians here are. Not all of our technicians are 30 years experience in the industry, but some of them are. And so we're calling customers who maybe don't have an RF meter, maybe don't have fiber meter, and it makes it difficult to troubleshoot, and it's through no one's fault. It's just lack of proper instrumentation. So the attempt here was to try and build some of that proper instrumentation into the system itself and eliminate some of the guesswork that does need to be done when we're doing remote troubleshooting. And again, the whole point of this was just to make it a much more customer-friendly system, easier to use, easier to manage. And along those lines, we actually have user management that can be set up in this. So we can do integration with SMS messages, send out emails, and one of the things that this is going to be monitoring for is obviously the change in state of anything in the platform. So if any wires are disconnected, if any baluns are disconnected, if anything like that happens, you are going to be notified of that. And that will be a big feature. And if you have a high enough level customer service agreement with us or an SLA with us, we will be notified as well. We'll actually set ourselves up to be notified here in the system. So yeah, let me jump back in here to the PowerPoint presentation, which is just an overview of this stuff. And then I see I've got a couple of questions. I apologize, I haven't quite been able to read them as I've been going through this. I'm trying to read them here as I jump back over. Let's put this back in. So, one of the last things that I wanted to touch on here, and you can see it in the bottom right corner, is one of the reasons that we felt like we were able to get rid of a lot of the bidirectionality within the system is because of the technologies that we're seeing out in the industry today. We see Samsung with their Link system, the ProCentric system from LG. RCA has just launched or has now rolling out a similar system, and basically that is communication from a server out to televisions either via an RF channel or over IP. And the communications went over an RF channel seem to be unidirectional. So what we were actually believing that we can accomplish with this system is that we can support these technologies. We can support ProCentric, we can support Samsung Link, we can support all of that with the 5th generation of the system without the bidirectional components. And those systems that are coming down the line that have the IP return path, we believe we can support those with the embedded switch. And it's my personal belief, I don't know that it's shared by everybody here at the office, that we're going to continue to see this as a trend where a lot of the return path stuff, remote broadcasting, all that is going to be done on the network. So we're compatible with all of those technologies. We pass the ProCentric commands. We pass the Samsung Link commands. We don't have any issues as is now, and we're able to do that as a unidirectional system. And I know I kind of referenced that briefly earlier in the presentation. I did want to come back and close the loop on that. And now I'm going to try and jump in and answer some of these questions. Please give me just a second to read one or two of them. Chad, can you, I know you're on, can you read any of these questions any clearer than I can? I can see like one line at a time. Aha, got it. And so, question from Corey Peterson. The answer is yes, you can use the existing 5002-1 or Balun QAMs on the 5th generation hub. So if you have a 3rd gen Balun, the 3rd gen Balun will work on any of the Gen 3, Gen 4, or Gen 5 hubs. The only place that you get into trouble is if you put a 5th generation Balun on a Gen 3 or Gen 4 hub. And again, feel free to shoot us an email if there are any questions on that. Ken, I see your question here. No, the new Balun still only requires the category cabling for distribution. So you're going to have category cabling in and then coax out to the television, set-top box, whatever it is that you are using to decode. So category cabling only going into the Balun, coax coming out. And then, and so I just got one come in here from Thad. So the amplifiers that are actually in the system are rated up to 1000 megahertz, 1 gig. We get a little bit touchy depending on what type of cabling that you have on the high ends of that over distance. So if you have a specific application there, we'd be happy to to talk to you about it. All of the internal amplifiers are rated up to 1 gig. But on some of your earlier versions of cabling, Category 5, Category 5E, even some of the early Category 6, your frequencies above 860 are going to be subject to some pretty significant roll-off, and we would want to be conscious of that. So if there's a specific application there, please feel free to reach out. And then, Russ, I do have your question here about the network issues and the 8 volts DC. I'm going to have Mark McNutt, our electrical engineer, reach out to you on that one. We have done plenty of testing on that internally and have never damaged any other equipment, but I will have Mark reach out to you and explain specifically why that is. And okay, I think that's it for questions that I have now. I did figure out how to blow up the question box. So I'm going to pop over to the last slide here. Oh, one more question. So Ian, that's a good question. With regards to the RS-232, we do have an existing RS-232 product, which some of you have deployed, and yes, a server controller is required for that RS-232 platform. We're at the front end of writing everything for the RS-232 and IR for the 5th generation of the system. So a lot of the command structure is going to be similar, but in terms of how we actually communicate, the final software isn't written on that yet. And one of the things that we want to do from a development standpoint is make a much more open API for communications than what we had on the existing system. So I don't believe you're going to require a specific server on the 5th generation of that RS-232. There is obviously going to be a ZBand software that we write, but there should also be an API that we have for any Crestron, Extron, AMX integrations. And then the questions just keep on rolling in. The 5th generation of the system, the ZHC, no, there's no 5 through 47 megahertz for return path, whether that's like FSK with a Sonify system, whatever, all of those frequencies are not there. We are keeping the 3rd generation of the system alive specifically for those purposes and those applications. So when we have that T-channel return path, we'll have a Gen 3 system, or it's a distribution REG system now under the rebranding available for any of those T-channel return path applications. Before everyone goes, I see we've already had some people start to drop off. There in your GoToWebinar template, there is a poll. The first one is just about kind of who you are, what you do, and then the second one is about other technologies that ZBand has that you would like us to do webinars on in the future. We want to make this more of a regular thing, covering all of our product sets. So if you would be kind enough to fill out those polls, it would be greatly appreciated. And then there were also some handouts embedded in the GoToWebinar link. You should have a flyer and a spec sheet on the Distribution ZHC embedded in the system. And if you don't have those, please feel free to reach out to us. The person that you want to reach out to is Chad Tully. It's CHADT@z-band.com. Chad is our marketing director who put all of this together and sent out all the invitations. So if there's any documentation that you didn't get, or any sort of that you wanted to answer the poll and didn't get to, please feel free to reach out to Chad or reach out to your territory manager. Haven't seen any questions pop in about 2 minutes, so I am going to call it a day if I don't get one in the next 30 seconds, and then everyone will get a follow-up email with a recording of this session so that they can take it back and view it or use it for training purposes. All right, I don't see anything coming in. Thank you all for attending, and I appreciate all of your time, taking 45 minutes, 50 minutes out of your day to spend it with us, and hopefully we will be hearing from you soon. Bye-bye.